Hello everyone, I'm Dr. Shivkumar. Today we will discuss about some more building materials which are extensively used in the construction, which are glass, polymers, and refractory materials. So let's start with the first material, glass. Basically, glass is a transparent or amorphous substance having homogeneous in texture. It is hard, brittle, transparent, or sometimes translucent material. It is the most common material which are being used in the doors, windows, curtain walls, and also for aesthetic purpose. The most common types used in building construction are sheet plate, laminated, insulating, tempered, wired, and patterned glass. There are lots of varieties available in the market of these glasses. Most ordinary colorless glass are alkali lime silicate and alkali lead silicate with tensile and compressive strength of about 30 to 60 Newton per millimeter square and 700 to 1000 Newton per millimeter square, respectively, and modulus of elasticity in the range from 0.5 is to 105 to 0.8 to 105 Newton per millimeter square. So the constituent, when we talk about the constituent, the major constituent of the glass is silica, which is used in the form of quartz, crust, sandstone, pulverized flint. It should be free from iron content for best quality of glass. There are some more material which are the part of this glass. Lime. It is used in the form of limestone, chalk, or pure marble, and sometimes as a marl. The addition of lime makes the glass fluid and suitable for blowing, drawing, rolling, pressing, or spinning. It is also impart durability and toughness to glass. Soda acts as an accelerator for the fusion of glass, and an excess of it is always harmful. Next is potash. It renders glass infusible and make glass fire resistant. So where we need the fire resistivity, we use the potash glass. Lead oxide. It imparts color, brightness, and shine. When 15 to 30% of it added to substitute lime, it lowers the melting point of the glass, imparts good workability, while its transparency is lost with the glass become brittle and crystalline. Next is cullets. These are the broken glasses added to act as a flux to prevent loss of alkali by volatilization during the process of forming glass and also to lower the fusion temperature. Classification of glass. Depending upon the constituents, glass are classified as soda-lime glass, lead glass, and borosilicate glass. So first we will discuss about the soda-lime glass, which are very common and used widely in the construction, in the glass doors, windows, etc. So soda-lime glass is also known as the soda ash glass, soda glass, or soft glass. The quality of this glass can be improved by adding alumina, magnesium oxide, and the glass is then called crown glass. This is the most common type of glass used in doors, windows that I have already mentioned, and also to making the glassware such as bottles, some showpiece, etc. The next is the Lead glass. It is also known as the flint glass. It is obtained by fusing some materials like silica, lead, and potash. It is free from the impurities like iron and it is colorless. Lead glass has high shining appearance and can take polish. Electric bulbs, optical glass, and some more types of ornamental glass, sometimes radio walls, are made from lead glass. The next and the finest quality of glass is borosilicate glass. It is obtained by fusing a mixture of silica, borax, lime, and feldspar. The best example of the borosilicate glasses are Pyrex glass and heat-resisting glass. Normally, borosilicate glass can withstand with high temperature and it is most suitable for the making of laboratory equipments like sometimes conical flask, burette, test tubes, and also these are using in a lunch box widely to make it microwave safe. It's easy to clean. It can be put it direct on the flame and it is unbreakable while putting on the flame. It can resist with the or it can withstand with the high temperatures mentioned in this slide. Next is the commercial glass. The commercial glass are mainly the sheet glass, which is used for glazing doors, windows, partition, and it is obtained by blowing the molten glass into the shape of a cylinder. And then the cylinder to produce a cutaway and cylinder is flattened over a plain tray. It is available in various thickness starting from 2 mm to 6.5 mm and is of various size like 1750 is to 110 mm size is classified or as required by the market. Now the uses of this glass. This is used generally for the engineering purposes, some class work, some superior quality work such as showcases, cabinets, some furniture, glass furniture, etc. Next is the plate glass. It is also used for engineering purposes and is superior to the sheet glass. A plate glass differs from a sheet glass in that it has a parallel distortion-free surface obtained by grinding or fluting process. It is produced by pouring the molten glass into the casting tables and leveling it to an uniform thickness. Both the glass surface are then ground, smoothened, and polished and is available in various thickness starting from 3 mm to 32 mm and sizes up to 2750 to 900 mm in length and width. Next is the tempered glass. This tempered glass is a form of plate glass and it is produced by reheating and sudden cooling mm, near about 3 to 5 times stronger than the plate glass. It resists bending, stress better than plate glass, and when broken, it is finely divided into small pieces. It is used extensively in sports arena, sliding doors, and curtain walls so that it may not harm. Wired glass. It is produced by embedding a wire of 0.45 to 0.56 mm into the center of sheet glass during casting. The minimum thickness of the wired glass is near about 6 mm. Not exactly. Wired glass is used for fire resisting doors, windows, and for the skylight and roofs. A special example of this wired reflective glass, which transmit 100% more light than the other glasses, and it is comparatively strengthened by providing this reinforcement of wired mesh. Next is obscured glass. It is made comparatively opaque to sunlight, also known as patterned glass, and they are classified as frosted, rolled, and ribbed glass. The frosted glass is produced by subjecting the polished face of the glass to a sandblast which grind off the surface. It can also be produced by etching on glass by hydrofluoric acid. The next is rolled glass, which is also a type of obscured glass, as a series of waves of desired pattern on the surface of glass and also known as figured rolled glass. Next in this series is ribbed glass. A series of triangular ribs are produced in that during the casting. The next in this series is laminated glass. It is made by sandwiching a layer of polyvinyl butyl between two or more layers of plate or sheet glass. It is also known as the safety glass. In the previous time, it was extensively used in the automobile, like in bus, in trucks, so that during any collapse or accident, the piece of glass should not fall into anyone and does not cause harm. So it is uh, during the breaking, it is adhered to that lamination and fused with that lamination and hanging over there, so that during the maintenance it can be removed easily and does not cause any harm. The example are heat-proof glass, soundproof glass, and bulletproof glass. The first one is the heat and soundproof glass. Two or more glass plates are sandwiched by a tinted plastic inner layer. It is provided high resistance to the heat and glare. By increasing the thickness of plastic layer, the glass can be made more sound resistant. Next is bulletproof glass, which is produced by placing vinyl plastic and glass in several alternate layers and pressing them with outer layer of glass. It is used in the banks, jewelry stores, and sometimes in the automobiles of some VIPs. Insulated glass. It is composed of two glass plates into which a layer of 6 to 13 mm thick dehydrated air is sealed. The round edges are formed by fusing together the two glass plates. These glasses reduce the heat transmission by 30 to 60%, and these are extensively used in the Gulf countries in the windows and sliding doors to reduce the heating. Next is the heat absorbing glass. It is bluish green in color and cuts ultraviolet rays of sun. The example is Calorex, which is used in railway cartridge, factories, hospitals, health clubs, and kitchens. It increased the efficiency of air conditioner also. The ground glass in this type of glass, one face of plate or sheet glass is made roughly by grinding. It is used to maintain privacy by obstructing vision and at the same time allowing light. The ground glass is used for bedroom, toilets, and for making blackboard, etc. The block glass is next is the block glass, which is hollow sealed made by fastening together two halves of the breast glass. It is used for making partitions. The next is opal glass. It is also known as the milky glass and is produced by adding bone ash, oxides of tin, and white arsenic to vitrosyl 99.5% silica glass known as clear glass. The composition of 10 parts of sand, 4 parts cryolite, and 1 part zinc oxide. Next is enamel glass. It is produced by adding calcined lead and tin oxide to the ordinary glass, and composition is 10 parts sand, 20% lead and oxides of tin, and 10 and 8 parts of potash. In this series, next is optical glass. It contains phosphorus, silicates of lead, and little cerium oxide, the latter capable of absorbing ultraviolet lights and injurious to eyes. They are used to making lenses. Now, this is about the glasses, and we will move forward on the polymers. The polymers are also known as the macromolecules, which are larger molecules of colloidal dimension of 10 to 3 to 10 raised to the power minus 6 mm in diameter, having high molecular weight is near about 10,000 to millions. Some molecules called monomers, which undergo polymerization reaction and forms macromolecules. The examples of polymer material are resins, plastics, rubbers, etc. The rubbers are also known as elastomers and are high polymers having the unique property of undergoing large deformation under load and returning to their original shape and dimension on its removal owing to lengthening and shortening of the spread of polymer chains. Next is the classification of rubber. The rubber may be classified into the natural synthetic rubber and the rubber like plastic. So in that series, the first one is the natural rubber. The natural rubber is obtained by the plants which have the like Braziliensis and Gauele. So the latex or the milk produced by these plants is collected and then processing to make the final product, which is known as the rubber. The next is the synthetic rubber, which is based on the model of natural rubber and thermoplastic vinyl high polymer, which are being used to make the synthetic rubbers. And the use of the synthetic rubber are unlimited and used in various processes and various products. Like as far as the uses are concerned, it is used to make the conveyor belts, linings of tank, tires, gaskets, mountings, houses, insulation, toys, phenolaldehyde resins. With waste rubber, where waste rubber is used to make flooring tiles, etc. Rubber is also being used increasingly in the manufacture of foam, rubber foam, which is used in the upholstery and furniture. The next is the plastic. Plastic are made from resin with or without fillers, plasticizers and pigments. These are organic materials of high molecular weight which can be molded to any desired form when subjected to heat and press in presence of a catalyst. Now the uses of plastics. Easy to work upon, light in weight, and a few varieties of glossy like glass rubber plastic are used. It are not attacked by the insect or fungi. It means it is termite proof, fungi proof, insect proof also. It is waterproof, available in desired color and texture, and there are so many varieties available of the plastic and can be used in various purposes. Now, in this series, the last material is the refractory materials. These materials are capable of withstanding high temperature in the different industrial processes. In addition to the thermal endurance, a refractory should be able to resist the chemical action as well as the heat. It should be the heat resistant material. There are some refractory materials which we'll discuss in this slide. The first one is the acid refractories, which are combined readily with bases. Their chief constituent is silica, quartz, sand, and ganister and silica bricks. So these are resistant to acid. The next is the basic refractories. It is consists of the basic oxides, magnesite, and dolomite. These are acid resistant refractories. And next is the neutral refractories. Consist of material which do not combine with either basic or acidic oxides, silicon carbide, chromite, and carbon. So this is about the today's lecture, in which we have discussed in detail the glass, plastic, rubbers, and the refractory, three types of refractory materials. So in the next lecture, we'll meet again with a new topic and discuss on plastering, pointing, and damp proofing. Till then, thanks to all of you, and I'll wait for you, all of you, in my next lecture, which I mentioned, the next topic. Till then, goodbye. Thanks once again.